On problem number 3, we're given a graph of a function f and a function g, and the area that is bounded by these two functions in the first quadrant. F is the function 8x cubed, and g is the function sine of pi x. They're labeled on the graph, and in part A, we're asked to find the equation of the tangent line to f at the point when x is 1/2. So let's get started. We're going to use point-slope form. We know that our ordered pair is provided for us on the graph. So we're going to say y minus 1 equals, and we'll leave a blank for the slope, times the quantity x minus 1/2. Now our job is to find the slope. We have to find the slope of f at that point. So here we go. F prime of x is going to be 24x squared. Now we need to evaluate this when x is 1/2. So that's going to be 24 times 1/2 squared. 1/2 squared is 1/4. 24 times 1/4 is 6. So the slope of the graph of f is 6 at the point when x is 1/2. When we completed part A, we find the equation of the tangent line to f at the point when x is 1/2. Now we're going to move on to part B. Oops. In part B, they're asking us to find the area of region R. So remember that to find the area, we're going to integrate, and we're going to integrate with respect to x. So integrate from 0 to 1/2. And now we have to do the top function minus the bottom function. Let's take the top function is sine of pi x minus the bottom function, which is 8x cubed. And we're going to integrate with respect to x. Now, integrating sine of pi x, we use u substitution. So let's let u equal pi x. And du is going to be pi dx. And then to get dx by itself, we'll say 1 over pi du equals dx. So we have a u, and we have a dx, and now we can substitute. We're going to call this the integral of the sine of u times, let's see, dx, we're going to call that 1 over pi du. We're purposely leaving the limits of integration out right now because we've changed the variable. We could put different limits of integration in, but we're not going to do that right now. And then we're going to subtract the integral from 0 to 1/2 of 8x cubed dx. Remember that the integral of a sum or difference is the sum or difference of the integrals. Now let's see, the antiderivative of sine of u is going to be -1 times the cosine of u, or the opposite of cosine of u. Our constant 1 over pi remains the same. And if we integrate 8x cubed, that'll be 8x to the 4th power divided by 4. So let's see, we're going to get -1 over pi times the cosine of pi x, replace u with pi x, minus 8 over 4 is 2, 2x to the 4th power. And we're going to evaluate this from x equals 1/2. Oops, I lied. From x equals 0 to x equals 1/2. And there we go. That is our setup. And now it's time to do some evaluation. So we know from the fundamental theorem of calculus that's going to be something minus something. Put 1/2 in first. So we get -1 over pi times the cosine of 1/2 pi. We'll call that pi over 2. Minus 2 times 1/2 to the 4th power. And then over here we'll have -1 over pi times the cosine of 0 minus 2 times 0 to the 4th power. So let's see, the cosine of pi over 2 is 0. And 2 to the 4th power is 1/16, 2/16. So we have -1/8 minus, let's see, the cosine of 0 is 1. So it'll be -1 over pi minus 0 minus a negative is plus. So we're going to say that the area of region R is -1 over 8 minus a negative is plus 1 over pi. And that's it for part B. Let's take a look at part C. Now in part C, we're asked to find the volume of the solid that's generated when region R is rotated around the horizontal line y equals 1. So remember that volume is going to be the integral of area. So we're going to integrate from 0 to 1/2. And of course, we're going to take the constant multiple pi out in front. And now inside, remember, we're going to do big R squared minus little r squared dx. So first, let's find big R of x. To find big R of x, we're going to draw a segment from the axis of revolution to the far side of the shaded region. We're going to call that big R, and we'll do top minus bottom. So it's going to be 1 minus that bottom function, which is 8x cubed. So we're going to have the quantity 1 minus 8x cubed squared in our integrand. Now let's find little r of x. Little r is found by drawing a segment from the axis of revolution to the near side of the shaded region, and we'll do the top minus bottom. The top of this little radius segment is 1, and the bottom of this little radius segment is sine of pi x. So we're going to subtract the quantity 1 minus sine of pi x squared in our integrand. And they told us to set up the integral. We did not need to solve it. So we are done with part C. Thank you for watching the video.